Okay, while people are still joining, I suggest that we start. We have a busy schedule, so don't worry, there will be a coffee break and all the pauses so that you will be able to relax a bit. The very idea of this final workshop is to discuss the orientation, discuss the strategy, discuss the communication, and to network. This is the idea of the conclusion of a 3-year project. If someone doesn't know me, my name is Aleš Holobar. I'm the coordinator of the HybridNeuro project. And the HybridNeuro project is the reason why we gathered today. The project is finishing by the end of this year, so December 31st will be the last day. And I may add that it was adventure. It was adventure, a very nice adventure, because we are basically a family of very enthusiastic researchers. But it is an adventure because this is not a typical research project. This is coordinated support action, which means that it is pretty oriented toward communication, toward dissemination, communication, and discussion of directions, research directions with the different stakeholders. And this is reflected throughout the project and also in the workshop that will happen this week. We are all familiar with the Apollo space program, right? Right? It started with a dream. Kennedy said, landing a man on the moon and returning him safely to the Earth, 1960. Okay? What followed was a huge set of struggles and failures. You all know how the United States struggled with the Russia competition between them, space program, a lot of accidents, human victims, right? A lot of effort put in. Then incredible success. First humans on the moon, 9 years later. Incredible. So incredible that it inspired many conspiracy theories, right? Okay? But then, loss of public interest. Apollo 17 was the last mission, and I quote, there was every scientific reason to continue this. So, what went wrong? And what we can learn out of this? This a bit awkward introduction into the workshop tells you the goals of the HybridNeuro project. It is to disseminate, to communicate, and to synchronize what we are doing. We are eager researchers, but we are usually closed in our little labs, doing some wonderful stuff that no one knows about. Okay? We then appear in the scientific manuscripts, and we persuade our colleagues, but did we really reach out to the community? Did we really justify the public spending? Or even more, did we take care to guarantee or to ensure that in the next funding program, people will be still willing to finance the science? Okay? Good. What did HybridNeuro do in this aspect? Okay. Basically, the project is about the hybrid neural interfaces and their use in a wide sense. There are many application fields ranging from movement augmentation, rehabilitation, to the very communication, human-machine communication, and to my strong belief, soon to happen, human-to-human communication. We are all closing and hiding behind the online meetings, right? Do we have time to really meet and see persons? Or are we always in a rush, neglecting what is an essential part of a human conversation? Non-verbal communication. Online sessions, we all know, those who need to lecture during the COVID period, they all agree on what it was missing. And this was a non-verbal communication, interaction, feedback from the students or attendees to whatever lecture about how you are doing. While I am lecturing today, I'm scanning you, each and every of you. I am following your reaction. I am trying to judge whether you understand what I am saying. And this is lacking in the online communication. Okay? So hybrid neural interfaces in a wide sense of the use. Yeah, we are after the new research avenues of cerebro-muscular data fusion, motor learning, motor recovery, and movement augmentation, as stated in this slide. But this is a typical research agenda, okay? This is engineers building the rocket so that it could fly to the moon. It is not agenda of communication or dissemination of the research, okay? What about the communication and dissemination? We had quite a few workshops, 8 webinars. We are creating biomedical data repository, open science, so that we can share the data. This neural data is not always easy to reach. We are establishing international hub where we would bring together different stakeholders, ranging from the clinical sector to the industry and, of course, academia. And last but not least, the public sector, the humans who are enthusiastic about what this field of science is doing. It was a very, very intensive project in terms of communication. But I don't think that we fully closed the gap. These activities needs to be ongoing, and we need to spread the word, what we are doing. Those who were present last year here in Maribor know that we organized a summer school, quite successful, quite nice summer school. Another one was in Imperial this year. And you can find all this information on the project webpage. As we said, we organized 4 different workshops. This is the 4th one. Again, you have the recordings of the talks on the YouTube channel, everything published so that you can follow it. The webinars were trying to educate the young researchers, the ones that are entering this academic career. They were all very nice, all very interactive, but we will see what will the reach out of these webinars be. And we have rather large number of video recordings published on our YouTube channel. This is just a very, very quick overview of it. We are trying to document all the lectures that we are doing. And also this workshop, as I said, will be recorded, is being recorded. It is being transmitted online and will be published after the editing on the YouTube channel. So just be aware that if you ask any question between the lectures, you will appear. Your voice will appear, not your image, right? Your voice will appear on the recording. Okay. But did we do enough? Certainly not. The action needs to continue, and we are continuing it in the form of the hub, HybridNeuro hub. And this is quite a challenge because we are in the hyperproduction of all the information, correct? All the platforms are competing for our attention. And if I ask you, who of you is tired of this advertisement, probably you would all agree that you are tired. We are receiving excitations every day, every hour, every minute, and the natural response of the neural system to continuous excitation is inhibition. We start ignoring the stimuli. Okay? So in this respect, it is a challenge because we would like to make something that really matters long term, not tomorrow, not the day after tomorrow. And we certainly don't want to tire with the bunch of information that is flying out. Okay? So we are trying to be careful how many times we reach out and tell you something. We would much rather see that you check our website and then you reach out to us and ask. But the idea is that we create joint visions, that we address the joint pains, that we address the joint strategies in the development of all this. We are in the global world. We are competing with the companies that have a lot of money and very, very wild dreams. These are not the dreams of the President of the United States, the Kennedy. Okay? The Kennedy, when he expressed his dreams, he was talking about the public good. He was talking about the public interest. These dreams can be replaced with the private interest. And we all have a feeling where this leads to. And we as academia have a responsibility. We are able and we must illuminate the future that awaits us. We must, negative and positive facts or use cases that can follow from the methodology that we are developing. And hybrid neural interfaces are sensitive to these ethical questions. Okay? Yeah, we have a web page, we have a LinkedIn channel. We used to be very active on X. We somehow stopped our activity there due to certain disagreements with the policy of the platform. Okay. But we do try to reach out to the different people, and we have a workshop which is starting right now, which is dedicated to the discussing these questions that I just exposed. Okay, if you will run across over the agenda, you will see that each day has its own topic. Today we will summarize some basic information about the neural interfaces. Tomorrow, we will talk about the applications in the domain of movement augmentations. Thursday is clinically oriented. We will have speakers talking about the clinical applications. And Friday is about ethics, transparency, bias, and about the bridges between the natural and artificial intelligence. Okay? Friday is a particularly important one. All these days are important. All these days are very, very important if we want to really discuss where we are going in this I may say crazy world. Okay? So after me, Matej will talk, and Silvia and Mehdi, and then we will have student presentations. Tomorrow we start with Alessandro Del Vecchio, then Dario and Kiran will take the podium, and we will finish the lectures with Juan, who will talk about the funding opportunities. Again, there will be student project presentations. We might switch this topic into the round table for the students because the amount of posters that we received did not exceed the first session. So maybe we will a bit adapt this. Then on Thursday, as I said, we have Hatice and Maya and Dejan talking about the experiences in the clinical practice. And Monica and Alejandro will talk about the perspectives of neuromuscular signal dynamics, again, for clinical rehabilitation. We asked Nina to conclude this session with the vision, how to assess the corticomuscular coupling in a novel way. And this novel way is the result. It is a product of the HybridNeuro project. Then a very good friend, Hamid, will tell us on Friday something about standardizations and about the ethical backgrounds of the AI. And then we will conclude the workshop with the discussions. What have we learned and where we are going? Okay. This is the agenda for the week. Okay, so HybridNeuro research program. What are the dreams? More efficient human-machine communication. What are struggles and failures? They are classical. Things don't work as you imagine that they would, right? It is a back and forward process. It is many attempts to find the final solution, and the final solution, once you find it, seems very, very simple. And you're wondering what was wrong that I spent so much time in finding this solution. This is a research. This is a research. Many trials, many errors, and few successes. We need to be stubborn. We are not movie stars. We don't come and say a wonderful sentence and then we get published. Struggling. Okay? Success in the HybridNeuro. Very promising results. Public interest. Well, we can claim that we are yet beginning. So we are at the third year, right? Apollo failed after 12 years, so 9 years of success to follow, at least, right? What can go wrong? What can go wrong? We are building the neural interfaces in the era of the artificial intelligence, which is hungry for the data and harvesting of the data for the humans. What can go wrong? It's a rhetorical question. Do we need to worry? Large language models, they need trillions of data, trillions of gigabytes or whatever the unit is of data to learn, right? Large vision models, millions and millions of images. We don't have this kind of data in the neural interfaces, right? So we are safe for the next year or so, okay? Right? We didn't even know how much to measure. If I want to train the artificial intelligence to recognize the neural codes in human, how many measurements do I need to take? What task I need to measure? How long the recordings should be? Okay? Yeah, there are myths on the web, and then there are conspiracy theories and many, many things happening. So there is a hype. There is a huge hype. It is a question whether this hype has any scientific solid foundation. Okay? And we are different, aren't we? Each of us is individual. My mother, my father took very careful, well-planned step to educate me. That's why I become a full professor. I must be special. My neural codes, yeah, they are something similar to your neural codes, but come on, I'm special. Right? We all are. We are all trying to be. We are desperately competing for this attention of our tribe. We must be special. We must be unique. What does it mean for the artificial intelligence? Sorry. You may know all the remaining people, but you don't know me, Miss Artificial Intelligence. Correct or wrong? If you study the human brain from the information theory, and this is not my study, this is the study of Christoph von der Malsburg, you will find out the following facts. 1 gigabyte of genetic information required to build up the structure of the human body. These are the structural instructions, how to build the structure. Correct? Do they cover anything else than the structure? Do they also include some functioning, some behavior? Do we all behave in the same manner? Or do we learn to behave in the same manner? This dualism is frequently present in the history of science, in many, many, many disciplines. What are the degrees of freedom in the human brains that we need to learn? We need to learn the brains, right? That's the purpose of everything. Even today, you are trying to learn something. You are trying to change your brains. So what are the degrees? 19 billion neurons, each with the capacity of connecting to 50,000 neighbors. If you multiply these two numbers, you will get petabytes of information. And if you study the human brains from the artificial intelligence, current artificial intelligence viewpoint, you will find out that there is no enough information flow for humans to learn, train their brains in 100 years. And we get worried if the newborn is not learning in the first year. Correct? So there is an information gap. There is information gap between how fast we can learn and how much of information we need to learn. Okay? So if we are really tabula rasa, if we know nothing at the time we are born, how do we manage to learn so many different things in such a short time? And the suggested answer is that we share learning algorithm. So maybe I'm not so special. Maybe I'm not so different than you are. Okay, I like to socialize, so maybe this is a good news. We are more equal than we think. But this is a good news also for the artificial intelligence. They can learn about our behavior based on the population. And then they can quickly adapt to each individual to boost the performance. Okay? Okay. Happy face. Fake happiness or true happiness? Okay. You can decide on your own. Anger. Faked anger or true anger? This is a bit trickier, right? We are not so sure. The happiness was okay, but this second one is not fooling many people, correct? Movement. Healthy person, impaired, neurologically impaired person. You get some sense of information, right? I'm talking about the information spaces. I'm talking about the information that is there. It just needs to be harvested. Okay? This is what I'm talking. I hope it's a happy, healthy person, because this is one of our lab members. Okay? The information is there. The information is there, and when you start studying it, you get surprised how many things are reflected in the neural codes. There are many, many, many things. Our lifestyle, habits, pollution, environment, stress, physical activity, and then, of course, traumas, disorders, diseases. We always think that someone else will get impaired, right? We're counting on our luck. But when the luck switches, we completely change our perception. In a minute, one scan, one examination, and the perception changes. Okay? Motor system is a wonderful system. It is built to communicate. It is built to move. It is built to support all our activities, from voice to movement, whatever you can think of. Brains were developed synchronously with the ability of movement. But the information there is complex. There are several levels where the information gets mixed. The evolution is an artist. It built our nervous system on top of many attempts. So there are many, many parallelisms. There are many tracts going down the spine. And then they are mixed. We have an interneurons. We have a monosynaptic, polysynaptic communication. We have many different brain centers communicating to each other. And the very reality is that we don't understand completely how they communicate. But we know that we can measure. Where do we measure? We can measure the electrical activity of the muscles. We call it electromyography. And it is a very, very nice window into the human neural codes, the window that our lab at the University of Maribor specialized in. Okay? So, the acquisition methodology, you all know, advanced. We are more and more moving towards unobtrusive measurement, smart clothes, epidermal electronic, and so on. So the people will not even realize that we are measuring them or that they are being measured. We are developing for decades the software computer algorithm techniques that allow us to then mix this information in the electromyograms and come up with the neural codes. And we will hear about these algorithms throughout the workshop, okay? And we will discuss the properties of the algorithms a bit, and not from too much technical side, but from the end user viewpoint, because certain properties matter. They are very, very important when you want to interpret what you are seeing. And you need to know how to use the methodology, and then you need to be able to interpret the physiological results correctly. And this is a highly interdisciplinary field of research. Typically, if you are good in signal processing, you are not so good in the physiology. Okay? Or vice versa. Let's face it. We need a team, interdisciplinary team. And then if everything goes okay, you can decode many, many motor units, how many we will discuss throughout the workshop. And then we can dream about all the properties that we can extract out of this. We usually classify this information into two different classes. One is peripheral information about the motor unit territory, size, innervation zone, conduction velocity. So this is peripheral information. And then the central one, which is basically sequences of zeros and ones, timing of the neural activity. Okay. Okay. But there is another modality. There is a EEG. EEG is nice, right? Correct? You can hear what neurons are saying. This is nice. But there is not a single neuron. There are 90 billion neurons. How many microphones do we have in the EEG? Very few. So can we measure all this population with one microphone? And what if the things start to go wrong? There is one impaired person one impaired neuron in this population. Can you find it? We need very high sensitivity if you want to address neurological impairments at a very early stage. How do you recognize one or a few out of many if you use a very few electrodes? So you can directly record the brain activity, but you will have this dimensionality problem. By combining both techniques, by combining the EMG, which spreads the information across the human body, and with EEG, electroencephalograms, which basically record a very, very dense information, we can hope that we will do a better job interpreting the neural codes. And this, in essence, is what HybridNeuro was all about. Combining different measuring modalities, the one or several based on activity of muscles, and mostly EEG on the activity of the human brains to improve the results. And what Nina will show is that we are able to extract the cortical component that is coupled to the activity of the alpha motor neurons recorded from the skeletal muscle. The blue one is the activity of the alpha motor neurons. The red one is the cortical activity. They certainly share something. And the beauty of this approach is that it gives you really, really high temporal resolution. Those who are used to do the corticomuscular coupling assessment, you know that the existing techniques require tens or hundreds of seconds of recording, okay? What do we do then? We average out the corticomuscular coupling dynamics. There is no averaging in this methodology. Okay? Very nice result. So, there are a couple of fundamental questions that will go on. Question number one, how do the brain waves relate to the neural code that we extract from the skeletal muscles? This is something that we will try to answer also in this workshop. Question two, how many degrees of freedom there are in the neural codes? Tomorrow, we will try to answer this question. And question three, do different persons share the neural code patterns, or are these patterns person-specific? This is something that we will discuss on Friday, and I already started this discussion. So we have a few days to prepare your minds. On Friday, I will challenge you to speak and state what you are thinking about this. These things are important in the era of the artificial intelligence, but not only for the technical development. They are very, very important for patients. Okay? Professor Milan Dimitrievich, a very good friend, said two basic functional features of the central nervous systems are to conduct and to process. They provide everything that we human beings are. injury or neurological disease impair these two functions, leading to positive or negative deficits. It may result in something wrong with excitation. They may result in something wrong in inhibition. But rather than focusing on the deficits, it is more advantageous to elucidate in each individual the specific neural functions that remain available, to build upon them and design treatment protocol to optimize their effectiveness. This is what we will be discussing on Thursday. We are not inventing this for scientific publications. We are inventing this to help human beings, to help patients. And while we may have big scientific dreams of building a rocket for a moon, we must not neglect the bicycle or any other transportation mean that can be put into the practice in a clinical sector. Okay? I thank you for your attention. I wish you a pleasant week. And of course, you are warmly invited to post any question. Thank you.